In this tip and trick, we're going to have a look at some new technology from the Autodesk Labs website called Project Krypton. So I've navigated myself to labs.autodesk.com, and if you move down to the manufacturing area and you find Krypton, and we click on Krypton, it would take you to the page where we can go and download the actual application. So it tells you a little bit about Krypton. There's some demo videos over here, and there's a download now section. But what happens is once you've downloaded this inside of Inventor, in your add-ins, you will now see Krypton, Moldflow Krypton from Inventor. Right, the idea is that you can then turn this on, and what it does is it loads up three little icons down the bottom of your screen over here. Project Krypton is designed specifically for plastic component design, so you can turn it on and off depending on the components that you're designing. Obviously in this instance we're designing a plastic part, so we want Project Krypton to be turned on. Right, what it's going to do is it's going to go and have a look at a few things of the three down there. The first one being manufacturability, so are the draft angles okay, can we make the component? The second one being materials, is it a costly or is it a cost effective raw material? And the sort of third one down there is the environmental impact. So the first thing I'm going to do is I'm just going to click on material over here, and I'm going to go and have a look at materials that are available. So first off, we can turn on non-plastic, unable to be applied for injection molding rules, but we don't want to do that. We want to go and look at the uses. So you could go and say, well, in this instance we're going to look at electrical. We'll tick the electrical box. Attributes: thermal resistance, chemical resistance, or impact resistance. We're going to say thermal resistance in this instance. Okay, and that basically filters our materials down. So we now have an option of polypropylene, polycarbonate, PEEK, ABS, etc. So we're going to go and look at these now, and obviously you can see the costs of these. So if we're looking for something cost effective, polypropylene is very low, and from an impact point of view it's low as well, so we're going to choose that. Right, we come back down the bottom over here, and we'll now have a look at manufacturability. Has a little exclamation mark. Cost efficiency also has an exclamation mark, and material impact is right over on that scale, but it looks okay. So we click on these, and we have a look at the manufacturability and what's come up over here, and it says processability examines the part for potential problems. It checks the wall thickness, checks for undercuts, and it checks for draft angle. We're going to have a look at our alerts and processability. We have excessive cycle times, and that's because we have some really thick areas on the components. So the wall thickness is quite high and there's lots of material in here, so they're saying we're going to need excessive cycle time and possibly high clamping forces. It actually tells us that the wall thickness is outside the range for injection molding, and if we tick to highlight the regions, okay, it actually shows us on the component where these regions are, so it gives us a good idea. In reality, we'll probably land up, if we did mold this, with some sink marks in these corner areas, so it's quite a nice one. And then draft angle, very large number of regions have been detected, and looking at the component you can actually see that it's pretty square. So let's have a look at the draft angle. We'll highlight those regions. Straight away you can see that all of those sides there are square, and so are the vent areas. So those would obviously be regions we'd need to go and have a look at on the design. Just shoot back in there and unhighlight the draft angle. Okay, next one being cost, and it runs through and it breaks the cost down into the mold cost, the material cost, and the production cost. So you can see that the mold cost is relatively high, the material cost is really high, and the production cost is not too bad. So the alerts, production cost, very high cycle time, and that'll obviously come back to what we've seen under manufacturability. I imagine the mold cost being quite high is because we've got straight walls. And then obviously we can go back into our material, and there's a little material alert, or there's no material alerts actually. And the things it checks for is your carbon footprint. So you can see that the carbon footprint is quite high inside of there. Embodied energy is quite high as well. Recyclability is high, which is good, and embodied water is pretty high as well. If we look at the help file for carbon footprint, for instance, it'll load up a help file for us. Okay, this comes from the internet, from Autodesk's wiki help, which unfortunately is running a bit slowly in this video. But there we go. So carbon footprint is the measure of the amount of CO2 gas produced in the production of the selected material, and there's a source, etc. So from a beginner's guide to designing plastics, it's a really good start. Thank you for having a look.